Okay, hello, good day. So today we want to look at this question. Okay, so in this question we're asked to express 2 cos theta minus 3 sin theta in the form r sin theta minus alpha. Okay, so to be able to do this, let us start. So we will write this as 2 cos theta minus 3 sin theta is equal to r sin theta minus alpha. Okay, and this one can be expanded using the compound formula as sine, that is r sine theta cos alpha minus, because this one is minus, right, minus r cos alpha cos theta sine alpha, right? So r is here, right? R is here. Okay, now all we now observe from here is that the one with cos theta, the one with this one has cos theta, this one has sin theta. So we'll compare the two. And we'll also compare these two, right? So that's what we're going to do. Okay, let's bring them together. Okay, let's bring this one together. So we have 2 cos theta is equals to minus r cos theta sine alpha, right? Okay, cos theta is going to cut cos theta, right? So that means 2 is equals to minus r sine alpha, right? Okay, so from here, um, okay, this one as it is. Let's look at the other one. This is going to be minus 3 sine theta is going to be equal to this one, r sine theta cos alpha, right? And then sine theta is going to cut sine theta. So minus 3 is equal to r cos alpha, right? Okay. So if we square this and we square this, so squaring both sides. So that's going to be 2 squared, and this is going to be minus r sine alpha, right? We square this. So this is going to be minus 3 squared, then r cos alpha, that will be squared, right? So this is going to be 4, and this is going to be r squared sine squared alpha. This is 9, it's going to be r squared cos squared alpha, right? So if we add the two together, so let's say this is 1 and this is 2. So we say 1 plus 2. So that will be what? R squared sine squared theta and sine squared alpha plus r squared cos squared alpha is going to be 4 plus 9, right? So r squared is common, that will be sine squared alpha plus cos squared alpha, and that will be 4 plus 9, that's 13, right? Okay, this is going to be 1, right? So r is going to be square root of 13. Okay, that's r. Now how do we get the alpha? So if we decide to divide it with this, if this is okay, star, and this is star star, so we say star divided by star star, right? Okay, so that will be, for this one is going to be minus r sine alpha all over is equals to 2, and this is going to be r cos alpha all over minus 3, right? So r is going to cut r minus, this is minus here, this is minus here, then we're going to cut. So tan alpha is going to be 2 all over 3, right? And alpha from here is going to be tan 2 all over 3. Okay, you see this alpha, we need to determine its origin, because we need to know whether it is that is, we have a quadrant. Normally it's supposed, if it is in the first quadrant, it should be in this place. But we observe from here that sine alpha, from this place, sine alpha is, if this comes up here, that will be minus 2 all over r. So sine alpha is negative here. Now cos alpha is also minus 3 all over r. It's also negative. But if you look at tan alpha is what? 2 all over 3 is positive. So the only quadrant in which alpha is positive is the third quadrant. That is in this tan quadrant. We have A, S, T, C. All students take chemistry. So it falls into these quadrants. So this angle that we obtain here is going to be in these quadrants. This alpha is going to be here. But normally we have to get a quadrant from the horizontal axis, from this origin where it is 0. So we have to add 180 to that alpha to be able to guess the exact expression, right? So our alpha is going to be this plus 180 degree, right? So that's how we get our alpha. So our overall expression is now going to be um 2 cos theta minus 3 sine alpha, sine theta is now r. What is our r? Square root of 13. Then sine theta plus, okay, this is minus, now minus this, which is tan 2 all over 3 plus 180. Okay, so that is how we get the exact expression for this. So what is important here is that whenever we're doing this, we need to consider this, the sign of the sine theta, sine alpha, cos alpha, and tan alpha, to know which quadrant it falls in. Whichever quadrant it falls in, that is where we. So if it falls into this quadrant, so it means probably it falls into this quadrant. That will be 360 minus theta to get the value. Then if it falls into this quadrant, that will be theta minus, that is 180 minus theta. So for this one, it's going to be 180 plus theta, or alpha. I'm talking about alpha in this case. Okay, so this is the final expression. Okay, thank you.